Thank you all for coming back. You're very good. The first lecture we talked about joint speech. And I've learned more about joint speech in a Chinese setting since then. It's been very instructive. The next two classes, we learned to approach language in a different way from the way in the textbooks. In the textbooks, we meet discussion of something called Chinese and English with syntax and phonology that's used for passing messages. And that's a perfectly fine subject, but it does not answer the question I want to answer, which is what happened to human beings over 6 million years that changed us so much and allowed us to coordinate our activities. Now, in the next, today and the final lecture, I want to explore this territory. And here, I don't have one story to tell, there are many stories to tell. And because most people think of language in the first way, syntax, phonology, message passing, we'll keep meeting that story, but my interest really is getting behind that to find out how we use our voices to coordinate. So we'll be interested in speech and language, but as we saw with joint speech, music is part of this story as well, and music is not necessarily different from language. I'm including music in languaging. So we're used to thinking of speech and language as shown over there on the left, and music is something completely different. But in joint speech, we can no longer find the boundary. And I'm going to remind you just a little bit, when we looked at joint speech, how many different kinds of voice we found, some of which were not musical, some of which were very musical. So we had, oh, sorry, let's see.
I hereby declare on oath.
I hereby declare on oath.
That's not musical, and it's appropriate to this situation, which is swearing an oath. But I love those guys. That is that musical? I don't know, they're dancing. It's a bit musical, there's a lot of repetition. Here's a protest. Those are Irish students protesting, no ifs, no buts, no education cuts. It's not like speech, it's not like music, it's somewhere in between. And then, also in joint speech, we find this. Very musical. So there's no order and we can't keep them separate anymore. So we've been looking now at the voice from a strange direction. Joint speech is a peculiar way to look at the voice. And when we look at speech generally, we have many options. We can look at speech as a mode of languaging. And then we want to ask, how do people coordinate their activities? That's really my main interest. How do we come together, to work together, to behave together in a purposeful way? We can also look at speech as a special kind of sound. Phoneticians do this all the time. They typically take recordings, sound recordings, and look at the patterning of sound. That's a slightly different approach because it leaves behind the eyes, the whole body, the context. A lot of things get left behind, but it is a very interesting way to study speech. as patterning in time that you can capture with a microphone. We can also study speech as a special kind of movement. Now here I mean many kinds of movement, I suppose. Phoneticians look at how we move the organs of speech, the lungs, the larynx, the mouth, the jaw, the lips, the velum. That is very highly coordinated movement, a very special kind of movement. But we can also look at whole body movement. Here we can look again at the gaze and at the gestures. So there's no single way to look at speech, just as there's no single way to look at languaging. We're asking questions now about very many kinds of things. I use this little diagram to talk sometimes about something we've discussed before, which is if you stop thinking of music and speech as separate and we allow them to overlap, here's a continuum, and over here we definitely have very speech-like things. Sometimes you might be thinking in language to yourself. There's nobody else around, there's no sound, there's only you involved. So that's all the way over here. That's not musical at all. Then here's a situation where there's multiple people, and this is the situation we find ourselves in right now, where one person is doing the talking, other people are doing the listening, but we are doing this together. Yeah? I couldn't talk like this to an empty class. I need you there. And obviously you couldn't listen to this if I wasn't here. So we do this together. After class, we'll have conversations. And that's different. That's the next one over there. That's more democratic. We're on equal footing. You talk, I talk, you talk, I talk. We have this negotiation. We make sense together. And then, that's still not musical. That's still very speech-like as we're used to thinking of speech. But then we reach the weird territory of joint speech, where speakers and listeners come together. I like to think of this as being like a handshake. In a handshake, you can't understand a handshake by looking at one hand. That doesn't make sense. A handshake is done absolutely together. It doesn't separate into two things. So that's like joint speech. And we've just seen a wide variety from non-musical to musical. As we get more musical, something happens. First of all, we introduce a beat. That's why I've got drawn the clock there. Initially, maybe it's not very strong, but in the protest it gets stronger, and by the time we reach music, it's very strong. What does that do? It does two things. It makes it easier to participate, because anyone can join in. You don't have to know the words. But it also makes it cheaper to participate. If you swear an oath, it's not very musical, but it's very serious. If you recite a credo in church, you say explicitly what you believe. It's not very musical, but it's maybe the most serious words you can speak. As the musical elements enter the picture, it becomes less serious. And we all like to sing along to songs, sing happy birthday. That's not so serious. Yeah? No one's going to die for happy birthday. And then when we get into the domain of music itself, even we can leave the words away, and now we're fully in the domain of music. So we went on a journey from inside our head, through this room, through conversation, through joint speech, into the domain of music, and there was no border. There's no categorical difference there. Now, many of you will recognize these diagrams. This is the International Phonetic Alphabet, and up until about 1990, I would say, most research done in phonetics was interested in finding these elements, phonemes. The International Phonetic Alphabet was dreamed up in the 1890s, a long time ago, 100 years further back. And it had an interesting goal. It wanted to capture all the categorical distinctions that could be made in all human languages. So already in 1890, there was this belief that all languages share some kind of system, some kind of opposition. Now, it's over 100 years later. I'm not sure that's worked out. First of all, consonants here are very different from vowels here. Most languages will have clear categorical distinctions in their consonants. With the vowels, it's not so clear. Even in English, in the unstressed vowels, it's not clear to me that we have categories. Some people believe we do. I don't believe the data shows that. But I want to point out something else about this. This was a grand idea that all human languages are going to be understandable using the same concepts. What a European colonial idea. Immediately making claims for the whole of humanity. And it turns out this system is very biased. It's biased towards English, it was English phoneticians who dreamed this up. And it captures this English contrasts very well, and the more you look at languages very far from English, the more you have to keep adding strange things and building it out. So when you get to the languages of Southern Africa, for example, or the languages of the indigenous inhabitants of the Americas, you find it's difficult to shoehorn them into this system. This also has a bias towards alphabetic writing. This was dreamed up by people for whom phonemes were like letters. Now, here English is really a bit strange because English spelling is terrible. Yeah, English spelling is not phonetic. It doesn't. You look at the letters of an English word, it doesn't tell you how to pronounce it. That's a historical peculiarity. It has to do with the British Empire. We won't stay with that. So, up until about 1990, this was the concern of phoneticians. But since about 1990, in my opinion, phonetics has changed and prosody has dominated the field. Now, most work here has tried to think along the same lines, to find in the melody of the voice, in the timing of the speech sounds, in the structuring of the speech. They have attempted to find categories, symbolic units, tones, accents, pitch accents, phrasing, and there's been some success with that, but there's lots of problems. And you cannot miss the fact that what we're looking at here is the music of the voice. Not the writing of the voice, but the music of the voice. Intonation and tone are very similar to melody in music. Stress, prominence, and accent are very important components of musical rhythm. One thing is louder or stronger than another. And then there's the largely unresearched area of voice quality. Different languages use voice quality in different ways. Not all of it categorical, but that's very like changing the sound of your instrument. The cello does not sound like a flute. Yes, timbre we call that, the different quality of the sound. So these are all essentially musical, and none of them are easy to capture in writing. So maybe by treating speech and music as necessarily linked, as variants of one another, we might find out more about this languaging I'm looking for. But even if we stay with the traditional view of language, so there's Chinese, there's English, there's syntax, there's phonology, we find discussion of, for example, rhythm. Now, to a phonologist, rhythm looks like this. There's a metrical tree. Here's a word. Originality is the word. Originality. It's got two strong syllables, originality. So I've shown them here. There's originality. Yeah? And you can describe this like syntactic structure. You can describe prosodic structure using a tree. Strong, weak, strong, weak, strong, weak. So we've got strong, weak elements here, strong, weak elements here, a final weak element here. It looks like a phrase structure diagram. And this works for some things. You can describe a lot of things like this, but it's not, well, it's not really very music-like, it's very syntax-like, but it's useful. Time here is replaced by merely order, so there's no milliseconds here, there's just what comes first, what comes second, what comes third. And using this, you define units like stress feet, metrical feet, prosodic word. These are units that phonologists use to describe this kind of thing. Even here, we can use musical terminology, and it works quite well. So I found this lovely little diagram which uses musical terminology to show the rhythm of some standard English phrases. I'll just speak them for you. If you can read music, maybe you can see whether this matches. So we got hot dog, grape soda, apple pie, hot fudge sundae, coconut shrimp, Rice Krispie treat, chocolate strawberry, cinnamon oatmeal, milk and cereal, avocado toast, cheese ravioli, strawberry ice cream, chips and guacamole, tater tot casserole, pepperoni pizza. It's like a little drum lesson. And it works quite well. So even when we deal with stress and rhythm symbolically, we're doing so, there's music involved. This is musical. And so we need to think a lot about what we mean by rhythm as we extend this discussion. For many people, rhythm has to do with equal timing. That's a metronome. Now, that's boring. I'm not going to dance to that. Let's have a look at some other rhythm. Indian tabla drumming. Quite long, actually. If you've never listened to tabla drumming, go listen to some tabla drumming. It's fabulous. That is much, for me, this is much more rhythmic than that metronome. I can show this contrast visually as well. So there's an American painter, Belgian painter, Piet Mondrian, who was famous for this kind of picture. This is, I think, Broadway Boogie Woogie, I think this is called, and or Manhattan Boogie Woogie, I forget. People often describe his pictures as rhythmic because there's a sort of a repeating without repeating quality to it. But I don't think anyone would describe this as rhythmic. This is a grid. Let's put the two beside each other. This is like the metronome. It repeats, but it's boring. And this is, there's repetition, but there's much more in here. There's pattern. When something is evenly spaced in time, we call it isochronous. So the metronome is isochronous. A sine wave is isochronous. And that is relevant to rhythm, but it misses something very important. It misses this patterning that we put over the grid, over the sequence. So these are all rhythmic pictures. Bridget Riley, Andy Warhol, H.C. Escher, and each of them has repetition, but it has repetition with variation, and it has patterning built over repetition. So when we come to look at rhythm and we want to understand it in languaging, in speech and music, I think we need to maybe not focus so much on clocks and isochrony. That's important, but it misses pretty much all the meaningful elements of rhythm. It misses the thing that makes us dance, the thing that makes us move together. So, there is a big history of studying speech rhythm, even in the phonetic community. And it's a sad and sorry tale, but we have to tell it. You know the story, babe. Yeah. So here we're talking about an understanding of language that is entirely traditional. I'll call it language one, because we keep coming back to this, where we're talking about something like Chinese and English. Yeah. There's a game that has been played for 100 years now, called language typology, in which, well, no, it's less than, it's only about 50 years, in which people have tried to sort out the languages of the world into categories. Now remember, we discussed the notion of a language like Chinese and English before, and we said it's a very abstract notion and it bears a complicated relationship to what people actually do with their voice and their body, and it requires a great deal of standardization. We need textbooks, we need school syllabuses, we need people to say that's right, that's wrong, we need writing in order to construct these things. So sorting them into classes is a bit odd. But it's a kind of a sport, so we'll have a look at it. Rhythm provides one basis for sorting languages into different classes. And, well, let's listen to some examples. I've got some speech here from a few languages. We'll listen to some Italian, Swedish, Yoruba, from West Africa, and Mandarin Chinese. I want you to listen to them with your musical ears. So put on your musical ears now. Click, click. Now let's listen to a little bit of Italian.
Adesso parliamo di Alitalia. L'accordo finale è previsto per domani con la firma anche delle associazioni che rappresentano hostess e steward, gli assistenti di volo. Intanto due grandi compagnie straniere, la tedesca Lufthansa e la francese Air France, si contendono un ruolo nel futuro.
Here's Swedish.
Nu är det slut för den här veckan, men vi ser oss på måndag igen.
Very different, I think. You'll agree that Italian does not sound like Swedish. We all can agree on that. Here's Yoruba from West Africa.
Nínú ìwé ìròyìn Daily Sun láti rí àkàrà kan tó sọ wípé.
It's a tonal language. It's got different kind of rhythm. And keeping your musical ears on. Here's a weird language.
我台记者从1、2、6日确认，广东惠州市2013年元旦春节期间。
I should have checked. I have no idea what she's saying. Is it okay? It's the news. Oh, okay, good. So, with our musical ears on, how would we characterize these differences? There's obviously something interesting going on here, yeah? But it's complicated and it's very musical and it's more than just boing, 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 boing. So here's the history of how phoneticians have looked at this. We go back 101 years ago now. Daniel Jones, great phonetician, said of English, because most phoneticians at that time spoke about English. Sorry. There is a general tendency to make the stress points of stressed syllables follow each other at equal intervals of time, but this general tendency is constantly interfered with by the variations in the number and nature of the sounds between successive stress points. It's a lot of words, and he's right. There's nothing wrong with this. It's a sensible observation. When we saw pepperoni pizza and hot dog, those musical notations were picking out what he's calling the stress points of stress syllables. And we saw that there's a certain regularity. But of course, when I choose my words to speak, I don't choose them based only on regularity. There's something I want to say. I want to talk about something. And so I choose words, and that interferes with this tendency. Daniel Jones was absolutely right. Here's a sentence. The originality of this research lies in its attention to details. Supposing I wanted to say this, I put little arrows there at the strong points. Here's the speech wave. Here's the envelope of the speech. And you can see that those strong points are roughly equally spaced in time.
The originality of this research lies in its attention to detail.
I didn't try to make that particularly rhythmic. You can see that because of the words, sometimes there's more syllables between these points, sometimes there's less syllables between these points. So, Daniel Jones, 1918, said something that was quite right about the patterning of stresses in English. 21 years later, André Classe did an instrumental study. In 1918, this would have been very difficult. André Classe used this device called a kymograph. You speak in here, and it moves a needle on a wax cylinder. It's very antique, it looks lovely. And technology has moved on since then. It's very easy to do this, but it was very difficult to do this back then. And so here's the kind of trace you get. Here's the word ham, here's the voicing, there's the onset, here's the word sinking, 2 syllables, sinking. These lines are drawn at what Daniel Jones called stress points. That's the start of the strong stressed syllables. André Classe was able to take these measurements and show that Daniel Jones was right. This is the first empirical study. He said stresses have a weak tendency to equal spacing, but it's only a weak tendency. Now, both of these gentlemen were looking at English, of course, so we haven't yet got into this game of comparing languages. And what they're saying is entirely sensible. Now, we're going to stay with English for a little bit, and we're going to listen to some very, very well-spoken English. This is Martin Luther King in his most famous I Have a Dream speech. And I want you to put on your musical ears again and listen to this. Listen to the rhythm of it, listen to the music of it, because this is about as good as English speech gets, about as musical as English speech gets.
When we allow freedom to reign, when we let it ring from every village and every hamlet, from every state and every city, we will be able to speed up that day when all of God's children, black men and white men, Jews and Gentiles, Protestants and Catholics, will be able to join hands and sing in the words of the old Negro spiritual, free at last, free at last, thank God Almighty, we are free at last.
To my ear, this is pure music. I love listening to Martin Luther King, and we'll use this in order to, as an example, as we see the way that people continue to talk about speech rhythm. So in 1940, this is later, this is after Andre Classe's experimental study, a phonetician called Lloyd James distinguished two patterns in English speech. So he's not playing the game of types yet. He's just talking about English. He called one Morse code and one machine gun. So Morse code is the sequence of dots and dashes, like not regular. And a machine code is, of course, I don't know why it's a squirrel, but entirely regular. And what Lloyd James meant was that when we speak, sometimes we sound a bit like Morse code, sometimes we sound a bit like a machine gun. And we saw this in the Martin Luther King speech. If we look at the onsets of syllables, black men and white men, Jews and Gentiles, Protestants and Catholics, we've got different numbers of syllables coming in between these stress points, and we get this rhythmic alternation, but we have different, it's like in Morse code you've got dots and dashes. We have strong stresses, more or less regularly spaced, black men and white men, Jews and Gentiles, Protestants and Catholics, but in between those we've got lots of different numbers of syllables, sometimes one, sometimes two, sometimes three, Protestants and, Jews and, right? But there's also times when every syllable gets a regular onset. Speed up that day, speed up that day, every syllable is regular. So Lloyd James was writing before Martin Luther King's speech, but he could have been describing all the patterning that goes on in there. So let's just listen to that.
Black men and white men, Jews and Gentiles, Protestants and Catholics.
Compared with.
Speed up that day.
So far, everybody is saying very sensible things, right? And they're referring to speech styles within English. They're speaking of speech. But then things start to go wrong. In 1945, Ken Pike introduced these terms, stress timing and syllable timing. Those refer to what Lloyd James had called Morse code and machine gun timing. Because in stress timing, the onsets of the stressed syllables are more or less equal, and in syllable timing, the onsets of every syllable is more or less equal. So these are just different names for machine gun and Morse code. But both of these are to be found in speaking when we speak English, if we're speaking well. The speed up that day syllable timing is probably rarer in English and maybe more common in other languages like Spanish. But then this was misunderstood. In 1967, David Abercrombie, who was otherwise a fine phonetician, said this: as far as is known, every language in the world is spoken with one kind of rhythm or with the other. And he said there's syllable time languages, which would include French, Telugu, Yoruba, stress time languages, English, Russian, Arabic, Mandarin, I think, would be syllable time. This is, we'll get to this. He claimed that every language is spoken with one kind of rhythm or the other. See how the discussion has changed? He's not talking about real speech, he's talking about these abstract things, like Chinese and English, as if each of them belongs to one class or another. And he illustrated this. He said, look, you can see that English is stress timed because he said, take this sentence here, which is the train for crew, please. We've got 3 syllables, followed by 2 syllables, followed by 1 syllable, and we've got 4 perfectly regular beats. Now, if you want to buy a ticket to Crewe, and you go up to the train station and you say, which is the train for Crewe, please? Or you don't even knock, you say, which is the train for Crewe, please? The person sitting there will look at you as if you are insane. That is not how we speak. Why did it come out so regular? Because he made it regular by tapping. It's like dancing. Which is the train for please. That's not how we speak. This turn of events was most unfortunate. It is false. Yeah? I don't like saying that because I like to say we have many stories in science. This story is false. Sometimes it's good to say, but it gave rise to hundreds of studies and a persistent myth that refuses to go away. I still fight this today in 2019. The idea was spread that there are two kinds of languages, syllable timed and stress timed. Some people added a third kind, mora timed, to accommodate Japanese. Mandarin Chinese on this view will be syllable timed. It's a terrible idea. It's simply wrong. It was not what people have been claiming. This is not what Daniel Jones had claimed. André Classe in the 1930s had shown that this is, he'd done this, the measurements required. You see, in 1918, the talk of speech rhythm was kind of abstract. In the 1930s, it became concrete because we had measurements and we could check. And we know the answer, and the answer is, in English, you find a weak tendency for stresses to be regular, but it's always interfered with by the other words. This is exactly what was said in 1918. And you can check this for any language you like. Here's some speech. See, these days it's very easy. We have Praat, we have recorders. We could do this check here, it would take us 2 minutes. Stresses in English turned out to be not more regular than stresses in Italian. But English was supposed to be stress timed, Italian was supposed to be syllable timed. Syllables in Italian are not more regular than in Swedish. Italian was supposed to be syllable timed, Swedish was supposed to be stress timed. So we listened to some English, some Italian, some Swedish, and there are obvious, interesting differences here, but this is not how they are different. So, surprisingly enough, this story didn't go away. Why? Well, people like to publish papers, people like to do experiments, and the idea that you could categorize languages gives you an infinite number of papers. All you have to do is say, I see we haven't looked at meow yet, but we've got to find out is meow syllable timed or stress timed. We know it has to be one or both, one or other. So we go record some, find it's not clearly one or the other, we'll publish. And there's lots and lots of papers that do this. Here's a language, oh, it's not clearly one or the other, publish. Right? That gets tedious and boring after a while, so there was another finding which kept this story alive, and it comes from the laboratory of Jacques Mehler in Paris, who made an interesting finding. He found that newborn infants, so just popped out, they can differentiate between, if the infant is born into an English-speaking society, it can tell the difference between English and Japanese, but not between English and Dutch. It can tell the difference between, so English and Dutch to a newborn infant born into English or Dutch society is, they're more or less the same, and they sound different from Spanish and Italian. Now, just because you're born doesn't mean you've only started hearing. Infants hear in the womb, and what they hear sounds like this. They hear low-pass filtered speech, which tells, so they've been hearing for a long time, they've been hearing the sounds around the mother. And we know from what we heard that there are musical differences, I'll just call them musical differences, between Italian and English, for example. Now, if you mix up these classes and you try to see, can the newborn infants tell the class English and Spanish from Dutch and Italian, they can't. Well, now, I hope you can see what's going on here. This looks like evidence for syllable timing and stress timing, but it's changed the game. It's no longer based on measurements of equal timing. It's based on newborn infants' reactions to musical properties of the voice. A good story that gets lots of papers published will not die. It will not go away. So people became very creative, and they found new ways to try to identify stress-timed and syllable-timed languages. And so a new game began of rhythm metrics. Rhythm metrics work like this. We want, because we believe that there's syllable-timed and stress-timed languages, we want to find something to measure that will keep them apart, that will tell me which class it belongs to. So we'll take speech, and we'll stick it into the grinder, and out will come some kind of measurements. And hopefully, these will allow us to keep this nonsense distinction between stress-timed and syllable-timed languages. And now we've got lots of work for phoneticians to do. There's no limit to the number of things we can measure. So here are some things. They're complicated. Look, this is really complicated. NPVI. What NPVI is you take the stress syllable onsets here, and you ask, well, do successive intervals, are they likely to be similar or different? That's all that formula means. Delta C here means we measure the duration of the consonants and see how variable they are. Percent V means we measure the percentage of the utterance that's vocalic. And here are some other ones. RPVI, Varco V, Varco C, YAR. There's no end to the nonsense. We're trying to enforce a category distinction where there is none. So here's the game. You can keep coming up with these, and here's how you play the game. You get a very few speakers, maybe 5 speakers, to read, not speak generally, but read a very few sentences, written sentences, in their language. Then you calculate your magic number, and you try to see which class it belongs to. Is it syllable timed, or is it stress timed, or maybe more at times? And then you make broad, sweeping claims about the nature of English and Chinese. So you end up with phonetic papers that look like this. Here's English and Dutch somewhere up here, and here's French and Spanish. Look, they're clearly different. Here's Dutch and English, and here's French and Spanish. Here's French and Spanish, and here's Dutch and English. So all these Dutch and English and French and Spanish. No, Japanese and German are in there too, and you can find other languages in there. You're trying to keep them apart so that you can claim they're stress-timed or they're syllable-timed. It's my unfortunate task to suggest to you that this is a very silly game to play. We're constructing something badly here. I don't mind, scientists construct things all the time. We introduce measures, we have standardized tests, we have experimental controls that allow us to carefully make distinctions that matter in the real world, that turn out to be useful. This rhythm metric game is not doing that. Right? And yet, in 2019, especially in applied language journals, in like L2 learning or sociolinguistics or journals that don't know the phonetic history, we find people talking about syllable, oh, this Italian is syllable timed, English is stress timed, Chinese is syllable timed, Japanese is mora timed. We find these terms being used because once you introduce a distinction like this, it's very, very hard to kill it. I have spent 20 years trying to kill this distinction. I fail. It's not gone away. But I did get to work for the Journal of Phonetics, and I did get to say when papers came in, no. But it doesn't stop it going on elsewhere. Yeah? So when you see someone describing a language as syllable timed or stress timed, what they are doing is describing a musical property which is complicated, which is not well described using this kind of typology, and which does not sort languages into discrete classes. So, let's take a 5-minute break right there. That's the game of speech rhythm. It's a sad, sorry game. So, let's look at rhythm in a different way. I'm more interested in how people coordinate. And we said at the start, you can look at speech in many different ways. And when we talk about rhythm, instead of talking about equal timing, which is all that the syllable time, stress time debate talks about, we might be interested in patterns built over repetition with variation. So, musical ears back on, we're going to listen to some joint speech again, different kinds of rhythm. That's a rather violent protest with a very strong boom, 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 boom rhythm. That's an Egyptian protest again. Frequently in the Middle East we find children or women leading a chant like this. But that's much more musical, I think. And then, getting away from protest, we had this example when we watched joint speech. He's having so much fun, isn't he? This is all speech. I think we can agree that. It's very rhythmic, and it uses the whole body in each case. Yeah? Whether it's the single beat, scum, 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 or this dancing thing, it's whole body. Now I want to just consider a simpler body rhythm, whole body rhythm, which is walking. When we walk, we repeat something. It's not very musical, but the body can be used as a walking machine, in which case the whole body organizes itself into something that looks like this. The two legs become non-independent of each other. The arms are pulled into it. The head even moves along with them. Everything moves together in the cycles. And the two cycles of the legs are linked. There's lots of repetition and there's not much pattern. This observation applies to any animal that walks. So here's a couple of animals. Spiders have 8 legs, millipedes have I don't know how many legs, dogs, horses. Whether you've got 4 legs or many legs, what you find is when you use your whole body to do a repeating pattern, there are certain principles. There's something that these all have in common. And if we understood that, we would understand something about how the body can be used as the basis for rhythm. Now, here's an illustration of the generality of these principles. You can walk with your fingers. Let your fingers do the walking. It used to be an advertisement. And it's that principle that we want to understand. Now there's a great deal of work done here by movement scientists on locomotion. The stuff I want to tell you about comes mainly from Scott Kelso, another Irishman, in a field called coordination dynamics. And we're only going to take a small little glimpse of this work, and then we're going to come back to speech to see what we can learn here that might be relevant to speech. So Scott came up with a task, shown here, move your 2 fingers in time to a metronome. And if you move your 2 fingers in time to a metronome, what we can do by using our hands, there's exactly 2 ways to do it. Here's one of them, where the, there you go. So you can do it like this, or you can do it like this. And there's no other way to do it. So there's a general principle here, which is that when you organize multiple body parts in a repeating pattern, they have a fixed relationship to each other, and there's only a few fixed relationships. Now, any of you who've ever ridden a horse know this. The horse will walk, trot, or gallop, but there's no halfway. Any of you who've ever used your own legs will know this. You can walk at a certain speed, but if you go up beyond a certain speed, you have to reorganize into what we call a run. Yeah? And you slow down, you go back to a walk. Now, so this system captures some of that. We can use this in the laboratory. It's a very easy system for doing experiments on. We don't need to take horses into the laboratory or run a long way. We can just sit down and do this to try and find out what we can find out. Now, it turns out that this particular system, this experimental system, has 2 stable forms at most speeds. This one and this one. I'm going to call this the in-phase pattern. I'll explain it in a minute. I'm going to call this the anti-phase pattern. I'll explain that in a minute. But when you speed up, if you turn up the knob, then this one's fine. We can go as fast as we like this. Well, there's a limit. But, if we do this and we don't, but if we speed up this one and we don't try and stop it, the hands reorganize and they start flapping like this. So they switch from one pattern to the other. Here you can see we start off with each hand out of sync with the other. So when one hand is here, the other one's out there. But as we speed up, they switch and become this pattern. That's what's shown here. So we start off in anti-phase, as I called it, and we end up in phase. Now in this particular system, if you slow down this, it doesn't switch back. So it's different from running and walking, but it has some general principles that allow us to investigate and model whole body organization in repeating patterns. When a pattern repeats, we need some way, some technical language, to say where something is in its cycle. Now, we do this, the sun comes up in the morning, goes down in the evening, and this repeats every day, and we divide that into hours. Yeah? So the hours tell us where we are in that pattern. But here we want to say where we are in this pattern, so hours won't do. We usually use the clock to say where we are in respect to the sun. But here we want to say where we are, where each hand is with respect to each other, and we're going to use this notion of phase. If we have a cycle, then phase is a word that just describes where you are in the cycle. This turns out to be useful not only for studying locomotion and speech, but engineers and mathematicians use this all the time. And because everybody needs something like this, there's many ways, many conventions used. Sometimes people describe phase using a number between 0 and 1. So if we start here, that's 0, a quarter, a half, 3/4, 1, and we go back to 0. But if you remember some mathematics, you can also describe a circle as having 2 pi radians. Don't worry if you've forgotten this, it doesn't matter. Okay, so sometimes the number is from minus pi to pi or from 0 to 2 pi. This is the problem when you've got engineers here, mathematicians here, physicists here, they all use different conventions. It doesn't matter. What we're talking about is where we are in the cycle. Now, if something is repeating in a very, very boring fashion, like a sine wave or a metronome, then phase just describes where you are in this overall repeating thing. So for simple periodic patterns, phase is a great description of, it's a number that you can assign to say where you are in the pattern. I like to think of it differently. And I'm not a physicist and I'm not a mathematician. I like to think of phase like this. What's the right time for the fish to be here if the bear is going to catch the fish? Well, the right time is not given in seconds. The right time is when the bear's mouth is here. What's the right time for the bear's mouth to be here? Well, it's when the fish is here. Right? For the bear to catch the fish. Needs really good timing. But the way to understand this is not in seconds, it's in the relation of one to the other. So that's the kind of way we're going to think about time now when we look at how the body becomes a system for engaging in repeated behaviors. So phase, in other words, is time made meaningful. If these are two things that happen, the red thing happens and the blue thing happens, I could describe them with respect to the usual way we measure time in seconds. I could say this started at 3 o'clock, and then at 3 minutes past 3 this started. But that misses something. If I want to describe the relation between these two, then I say where this starts as a point within this overall red event. So this is point 6 of the way through. Phase is this way we have of talking about where one thing is with respect to another thing. It's a very general idea, it's a very powerful idea, and it allows you to do some mathematical modeling of things like this. Now we're not going to do much mathematics here, I promise you. This is all the mathematics we're going to do. This is a mathematical description of a system in which there are two patterns, this one and this one. In one case, the phase difference, this one, the in-phase pattern, has the hands doing the same thing at the same time. So there's no difference in the phase of this and this. So the phase difference is always 0. And that's 0 here. And in this one, they're exactly a half, or in this notation, pi radians out of phase. So that's this one. And because it's a repeating pattern, it doesn't matter whether you're a half a cycle ahead or a half a cycle behind. Now we can describe the transition from one form of organization where there are two patterns to a form of organization where there's one pattern. And this, I've hidden all the mathematics, this is really easy. Equations can capture everything we need to describe how a system can have these two patterns. I don't want to do the mathematics. People don't like equations. It's bad for the stomach or something, I don't know. What I want to do is just show you that this idea is very powerful. And it allows us to capture a lot of regularity in the biological movement. So one fun experiment that Scott Kelso went on to do was to strap his postdocs and his PhD students into a chair like this. Now this turns you from being a two-legged animal into being a four-legged animal. So these people have never been four-legged animals. And what they find is the four limbs organize into regular patterns, four limb patterns. There's exactly 4 of them, and when you speed up, this becomes this, and this becomes this. Just like in a horse. Now these people have never practiced this. This is coming from the physical nature of the body. Don't do this, but if you take a centipede and you pull off its legs in pairs, don't do this. This is an animal with very, very, very little brain. But it reorganizes fluidly. It doesn't need to practice. It's never had this new number of legs, and it can walk perfectly with them. There's no practice needed for this. The body self-organizes. So we're looking here at general organizational principles of the whole body. Why am I talking about walking so much? We're going to get back to speech now, because we're going to take this and we're going to ask, what does speech look like if you think like this? This is work I did a long time ago with my PhD supervisor, Bob Port. This is my friend Kenichi Tajima, who's now back in Japan. And we developed a method called speech cycling. What we did was we got people to do something which is artificial, it's a laboratory task, in order to see if there were general principles that could apply to speech as well as to other forms of movement. So we got them to repeat short phrases. And here, an example phrase is big for a duck. You've never heard this before, Blair. And we play a metronome for them. So here's a high tone and a low tone, and a high tone and a low tone. And we'll ask them to say, big for a duck, big for a duck, big for a duck, big for a duck. Now, experimenters can do things. I can move the phase of this low tone within this overall cycle. So I can place it halfway there, and then this becomes very, very easy, and it sounds like this. Big for a duck, big for a duck, big for a duck, big for a duck. That's boring and easy. But I can move this, and I can place it just a little bit later, or a little bit earlier, or a lot later, or a lot earlier. And if there's no, if speech is completely unlike walking, there's no reason why I couldn't also move my duck around a little bit later and a little bit earlier. So here I'm going to move it up to, instead of halfway between, this is 0.6. This becomes a lot harder. Big for a duck, big for a duck, big for a duck, big for a duck. I can do it. I've been practicing this for 25 years. I hate to say. So what we did was we had people try to place duck anywhere from here to here to here, anywhere from 0.3 to 0.7. And if there are no rhythmic constraints on speech, they should be able to do it. So we draw the target from this range equally likely. And then we measure, where do they place duck. It wasn't just duck, there's many phrases. Where do they place this? And if they can, if there's no strong constraints like there are here, then they should be able to reproduce this distribution. But they don't. They clearly don't. Here's 0.3, here's 0.7, and this person produces 3 patterns. Here's 0.3 to 0.7, and this person produces 3 patterns. This person produces 3 patterns, and this person produces 2 patterns. There's always one subject, isn't it? So something's going on here. They're not free to place the duck wherever they like. Just as you're not free to place any arbitrary relationship between your hands, there's 2 patterns here. But speech does not look like legs. Right? Speech is very different and it's very complicated. But we're finding that there are 3 and only 3 stable production forms. We did a lot of experiments to test this and move things around, but there's 3, but we didn't know this going in. You know, it takes about 30 seconds on a bar stool to find these 2 patterns. This took a little bit more work in the lab, but there's 3 patterns. And the phases that they produce are 1/3, 1/2, and 2/3. They make sense. I'll show you why they make sense in a second. Now this person only produced 2. He didn't produce this 3rd one. I can show you what these 2 are. When we place it at 1/3, we get big for a duck, big for a duck, big for a duck, big for a duck. When we place it at 1/2, we get big for a duck, big for a duck, big for a duck, big for a duck. When we place it at 2/3, there's a little reorganization necessary. We go big for a duck, big for a duck, big for a duck, big for a duck. So 4 just became strong. This person didn't find that. Once you point it out to him, he can produce that one too. So people don't necessarily find all the patterns that are available, but there's exactly 3 patterns. Now this is a lot of words. What this means is that the way that all the body is organized in speech resembles what we find in the legs. It resembles what we find, what it is that's common between a spider walking, a millipede walking, a horse walking, your fingers walking, a 4-legged PhD student walking. What we find is entirely consistent with the limb results. But this does not look at all like a pair of legs. It looks very, very different. So I think this is exciting because we've discovered some general principle. And now if I want to describe these 3 patterns to you, the easiest way I can do that is using musical notation. There's the 3 patterns. Big for a duck, rest, big for a duck, rest, big for a duck, big for a duck, big for a duck, big for a duck. You can see why the music is really, really important here. And this is a completely different story about speech rhythm than the one we told when we were looking for stress-timed and syllable-timed languages. What we found then is that speech is rhythmic in a strong sense. That is, you can, when you get people to repeat things, it's a very artificial task. When you make people repeat things again and again, then they fall into patterns without practice, without thinking about it, simply because of the way bodies work. We didn't need to talk about brains at all. We didn't need to talk about computation or timing. This is how bodies work. Now, what does rhythm mean in this sense? There are many senses of rhythm. In this sense, rhythm is a kind of an organizing principle which takes very many parts of the body and makes them work together, simplifies them. So I can do lots of things with this hand. I'm doing lots of things with this hand, and this hand's not doing anything. Now I'm going to stop doing things with this hand and I can do things with this hand. My hands are independent of each other. But when I ask them to wag in time with a metronome, they're not independent of each other. And so in a sense, they're simpler. I would use less numbers to describe the 2 hands, because if I describe one hand, you know a lot about the other hand. If I say this hand is here, you know this hand is either here or there. That's only true when I'm doing this task. It's not true generally. So 2 hands have, when you describe them mathematically, you can say where it is in the cycle and how fast it's going. That's 4 different numbers. But when they're coupled, that is when they're locked together in this task, there's only 1 degree of freedom. We've gone from 4 degrees of freedom to 1 degree of freedom. It's become simpler. This notion of degree of freedom is very, very important. I said the speech production system doesn't look anything like a pair of legs. It has very many degrees of freedom, very many things that can potentially be controlled independently. But when we make it engage in a repeating behavior, it becomes simpler. It becomes a repetition machine. Here's a lovely illustration of it. This is a machine doing something I can do as well. I can drum my fingers. Now I can do lots of things with my fingers. Some of them are rude, I won't do this, but I can do lots of things with my fingers, gang, hand signs, and sign language. But if I choose to do this task, all the fingers become non-independent, and I can only control the speed now. I can make it go faster, I can make it go slower, but it's a very difficult thing to try and change any one part of this without changing everything. So this illustrates it. When I choose to do this, my hand has basically become a machine for this purpose. And now it's stopped being a machine for this purpose. When I walk, I become a machine for walking. When I stop walking, I'm free to dance or climb or whatever. So what I'm going to finish up now, I think, for today. What I want to say is that rhythm is so much more than this. Rhythm is so much more than tick, 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 tick. It's much more than isochrony. Rhythm has to do with coordination. And coordination has become of great interest to us as we try to understand what happened to humans over the last 6 million years. How did we come to share a world? How did we become non-independent of each other? How do humans work together? When we investigate rhythm, and we stop thinking about English and Chinese, and we start thinking about bodies, what we see is that there are patterns that emerge, patterns that coordinate our movements. These two dancers are beautifully non-independent of each other. They are coordinated and they move as one. And they can stop that as well. We're not actually machines. We organize as if we were machines, from one task to another task. Now we'll pick up this story in the last lecture tomorrow, and we'll look at more about coordination in speech, and we'll look then at coordination and synchronization in movement generally. We'll spend a lot of time just thinking together to finish up this whole series. So we started off looking at a strange kind of language, joint speech. But it's not so strange because we're very familiar with it. It's just not studied. Then we unpacked the notion of language to find out that there's different ways to think about this, and the way that linguistics typically thinks about language misses an awful lot and does not explain what happened to our species. And then as we unpack this notion of languaging, we find all kinds of interesting ways in which we coordinate our behavior. And taking a cue from joint speech, when we now try to just wipe out the distinctions that we were born with. Let's wipe out the distinction between Chinese and English. Let's look at movement of the bodies and get rid of the distinction even between language and music. What we find are human behaviors are grounded in the body, and we make use of them to become non-independent and to share a world in the sense that these dancers are sharing a world. So that's where we're going, and I hope that the whole thing will make a coherent story. I'm going to stop there now, but if anyone has any questions, I'd love to take them.